So let's talk about these two words, authentication and authorization. So what is authentication going to mean? And if you have a better way of thinking about this, I want to hear it. Type that in. I look at authentication as a way of being able to say that I know who this person is and they are allowed to be here. That's the way I think of authentication. That you are somebody that is known in the system and you're allowed to be here. That's going to be authentication. Authorization is going to state what you're allowed to do now you're here. All right? Because just because you're here, it doesn't mean you get to do anything you want. Some people have higher level privileges than others. I like to think of it as like you went into a club or you went to an event, and some people have the VIP badge, right, which I never get. Well, they have higher levels of authorization. They can walk into that room and you can't. But both people are authenticated, right? They're known, they're on the list, and they're allowed to be there. So that's the way I think about these two things. And they're two separate problems that we tend to merge together into like a package or a solution. And we're going to do that too, but we have to kind of know where we're at. So let's start with authentication. And let's start with what it means to be authenticated with a token. And part of that conversation is I want to share with you kind of where the token falls off. For me, JSON Web Tokens are great because it's an industry standard today. You do not want to roll your own authentication. You do not want to roll your own authorization. I'm telling you this right now. Do not implement your own stuff. Because if you ever wanted to get that system certified, it's going to cost hundreds of thousands of dollars. JSON Web Tokens, at least, is an industry standard. All right? And OPA has become an industry standard in the sense that that's already been, right? You're not rolling it. And that's why I like these two texts. Okay, so how are we going to get to authentication with JSON Web Tokens? So we're going to have two situations here. Let's just say that we're going to have our browser app. Let's just say we have our browser app here. And over here, we're going to have our Go service. Right? The Go service is extending APIs, and that browser wants to access that, but we want to make sure that they're authorized to do it. So what do we do over here? I'm talking about semantics, and then I'll show you the mechanics. So what we're going to do is we're going to generate a private key. We're going to use that RSA algorithm. We're going to generate a private key. We're going to keep this thing private, okay? And then what we're going to do is we're going to generate one of these tokens with some header information and some payload information. And maybe in the payload for this token, we're going to put your user ID in there. So we're going to put your user ID in there. We're going to put some other information in there. Another piece of information in there we can put is like a date. We could say how long this token is good for. It's good for 20 minutes. It's good for 20 days. It's good forever. So maybe those are two core pieces of information that we store. So we're going to create some data. And what we're going to do is we're going to store some information in here. We're going to have your ID in here. And we're going to put some sort of expiration date in here. And then we're going to take our private key and we're going to sign this data, that signature. And when we take our private key and sign the data itself, all right, it's going to generate some, in our case, let's just call them random bytes. It's going to look random to us, but those bytes are reproducible every time we use the same private key against this data. And we're going to get this signature value. And we're going to take these two pieces of information and we're going to give it to this person over here. So we're going to say, this is your token. And again, it's not encrypted. So we could put this into this debugger, and we would see what the ID and the expiration date is. We would see what the signature looks like, though, again, this is something that can be reproduced with the private key. Okay. So we give this to that user who's building this browser app. And what we're going to do, we're going to tell this person, every time you make a call, I want you to send this ID and signature back over. I want you to send this to me. All right? Send this information to me. Okay. And let's say they make this call, and that's exactly what they do. They send this. All right. And again, it's encoded in this base64. So now what does the server do? Now, you need the private key to create the tokens. And in most systems, you even want to use a third-party environment to do that. Google's got stuff for that. There's other things out there for that. So most of the time, this token is not being necessarily generated by this Ghost service. It's being generated maybe by another Auth application that has that private key stored safely. And we ask that to generate the tokens that we're going to use. And we want to keep this private key very, very far away. So then how does this Ghost service going to be able to do the authentication on this when it doesn't have the private key? No problem. What we're going to do is set up another service called a key store. There's lots of key stores out there as well. We're actually going to write our own little in-memory key store to keep things simple. But Vault is a key store. You can use HashiCorp's Vault to do this. And in fact, when you run this from the service repo, that's why we're installing Vault, to act like a proper key store. So what we're going to do in the key store is we're going to create a key ID, maybe key 1, and we're going to store the public key pair for this private. We don't care who has the public key. That's the whole point. It's public. Anybody can have it. So it's not really a risk to store our public key in the key store, but there's going to be an ID. And that key store ID also gets stored in our token. So what happens? Okay, an API call request is made. What is the very first thing that we have to do in our Ghost server? Well, we're going to read the token. We can decode it. And the first thing we want to do is say, okay, what key ID is being specified in this token? And the token comes back and we read it and it says, oh, key 1. So we go out to the key store, or we've done this before, so let's say we cached it. But either way, we look up what the public key is for key ID 1, and we get the public key. Now here's the cool part. We can use this public key to validate that signature was signed by our private key pair. This is where the level of drugs on the math is unbelievable. And so we can use the public key through a bunch of math to validate that this signature related with this data was absolutely signed by the private key associated with this public key. And if that signature validates, if we validate that this was absolutely signed by the private key pair, we now have what I'm going to call first level authentication. It's first level authentication. We'll call it level 1. Level 1 because all we know at this point is that our private key did sign it, and therefore the token is something that we can trust at that point. Nobody else could have generated that token but us. Or if somebody steals our private key, that's a different story. So let's say nobody stole the private key, Therefore, we know nobody else could have generated this token but us. Okay, that's great. We now have level 1 authentication. But there could be problems. Level 1 authentication might be enough for some systems. For other systems, it may not be enough. Let me give you a scenario, okay? Because once we've authenticated the signature, the next thing we can do is look at the expiration date. So we've got a signature check. Okay, great. Signature check. Great. Now, we want to look at the expiration. Let's say that I created this token to last 10 years. It's a 10-year token. Just say I did that. So we look at the expiration date. Has it expired? No. Check. Boom. And now we let this person into the system. We don't reject the call based on authentication. In fact, I'm gonna pick on Matt a little bit today. So Matt, I gave you this 10-year token because we're friends, and I want you to use this system for as long as you'd like, right? Except, you don't know what Matt did to me yesterday. I'm not talking to Matt anymore. I won't even tell you because it's so horrendous, okay?
What you did to me. Pina Colada song out of my head.
So Matt and I are at odds on who hurt who. Either way, we're not talking to each other. However, I gave Matt a 10-year token, didn't I? And I say, Matt, don't ever use the system again. And Matt says, you can't stop me. And at this point, I can't stop Matt because every time he makes a call with this token, it's going to pass level 1 authentication. The signature's good, and it hasn't expired. Now, at this point in the architecture, I have only one way to stop Matt. The problem is, to stop Matt, I have to stop everybody. I have to switch out my key. I got to come in here and say, we don't use this private key anymore. We use a different private key. And now we've got key 2, which is a public key, and I can take this key out. The problem is now he doesn't pass signature because his key ID, we don't have a key anymore. But not just Matt is now out, everybody's out. Everybody's got to go back and generate a new key. That's a massive disruption. I don't want to do that, right? I can do that, and over time we do want to rotate keys, by the way. But over time, as you're rotating keys, you're keeping other keys still alive. Eventually, you might take it out of the system. That's where the key ID comes in. But how do I solve this problem with Matt? Because this could happen again. And this is why I say that the JSON Web Token is a really good foundational framework. But what we really need after level 1 is I'm going to call level 2. Most systems need what I'm calling level 2. They're going to have a database of users. And if you pass level 1, you go do a level 2 check, and we hit the database. Now, if I had level 2, I would have been fine. Because Matt would have sent his token in, it would have validated at level 1, and then when we went and hit the database to see if Matt is still in good standing, I would have went into the database and said no. And then Matt would have been out. So what I want to stress is that on many systems, not all, but on many systems, you probably need what I'm calling level 2 authentication checks. That the token itself is not enough because it may not give you enough control. Now you might say, Bill, why don't we, instead of giving anybody a 10-year, just give everybody an hour? Well, that could be a nightmare too, depending on your system. If somebody has to log in every time, yeah, then you can give them maybe a 20-minute token. But if this is some sort of API service, you don't want to have to go in every single time and create a new token every day because you didn't do, let's say, level 2 checks. So you understand what's happening here. Most of the time, and most of the systems that I've built, if you can get away with a tiny expiration date, level 1's enough. because it's expiring right away. What's beautiful about level 1 is that you never make the database call. So it's super fast and efficient. It's one of the things I like about the JSON Web Token, right? You can get level 1 authentication without any extra hops. However, if you have this need where the token has to be long-lived, you probably need a level 2 check, just so you have a little finer control. Okay, that is authentication. And most of the time, the system that is creating tokens is not the system that is consuming them. In this project, it's one and the same because I'm trying to keep things simple. Our service can both create tokens and validate tokens. And so I do everything with both private and public keys here. But that would be really unusual. Normally you have normally the system that's creating them is not the system that's providing your API and consuming them most of the time. But I'm going to show you the code for both. What about authorization? Well, I said that. Now you're in the system. The question is, are you authorized to actually access the API that you want to access? Are you authorized to access, it can get crazy, those fields, all the way down to the fields? Now, again, you do not want to hard code authorization to the extent possible. And it would be nice to be able to swap out or correct or fix or change authorization rules without having to rebuild a binary. And this is where OPA comes in, the Open Policy Agent. We're going to use OPA to apply authorization rules. Now, in this implementation, and I've done this on client projects, the OPA programming that we do, the OPA scripts, do get embedded in the binary just to keep it simple, which means if we want to change authorization, I have to build a new binary. However, there's nothing stopping us from putting the OPA scripts somewhere else and pulling them down and giving us the ability to change that. And this company here that has really built all of this sort of infrastructure for OPA, Styra, has services already that act as an OPA service that lets you manage all of these OPA scripts dynamically. And so that you don't have to embed them in your Go binaries. You can pull them down. They can be fixed. They can be changed if you had bugs, whole 9 yards. Sort of separates the authorization from your code. All your code is doing is downloading the scripts that they need and making sure that we're executing the right ones. All right? Remember, the config map is for static sort of things, right? You'd have to restart it. So you could use that for the initial scripts, I guess. What I'm doing, I think, is better because I just embed it in the Go program, and you have the scripts there from a development perspective. So if you're going to do that, I think that's better. But the idea that these scripts can be pulled on the fly, you know, and then there's some mechanism to update them if they get updated, to me is really cool. Because you've truly separated yourself from rolling your own stuff, and you're using industry standard stuff. So that's the idea. Now, this OPA language is super complicated in my brain. It's a lot of Boolean sort of logic. It's not, it has conditionals and things like that. I have very simple scripts, but it's all about true or false at the end of the day. So I'm going to show you some of this stuff as we go. And I'm sure there's other systems out there. And my point is that you really want something out there that works and don't roll your own. And OPA to me is pretty cool. So I'm going to show you that. But that's going to be the authorization piece. So once we're in, then we're going to say, at that point, we're not just going to have an ID and an expiration date. We're going to have something else in the token that we're going to call claims. And that's going to be part of that business data. If we go back here, your user ID and what we're going to call claims will be part of the payload data. And the claims is going to be data that will feed to the OPA scripts. And then the OPA scripts will look at that claims data and make a decision whether they can do something. Our claim data is going to be really simple. We're just going to define the role that you're at. And then based on your role, those APA scripts will determine whether or not you're allowed to access that endpoint or not. I'm keeping it simple. This stuff can get really detailed, involved if that's where you want to go. But again, at least it's separated. So that's it. Authentication and authorization. These are the semantics. This is what we have to build.